Okay, in this video, we're gonna try to find the determinant of the following n by n matrix. So let's call it A. Its elements are denoted by A, I, J. I is between 1 and n, and J between 1 and n. That means we have n rows and n columns. So this case means that A is an n by n matrix. Okay, and it has to be able to compute the determinant. So the coefficients of this matrix are given by A, I, J. So here, when I is equal to J, we have A plus B. So that means this coefficient is A plus B. When I is different from J, Aij is equal to A. So if we do that, we will obtain the following matrix. Okay, this is how it looks. So this is a short way of writing the general form of the matrix. So this is its expression when we do it explicitly. Okay, now our aim is to compute the determinant. Okay, so the determinant of A. Note in this case that A and B are in R. Okay, so these are real numbers. One way to compute this the determinant is that we can use the linearity of each column. Okay, and we can use that to simplify the looking or the way that this matrix looks. Okay, we can do that, and we're going to use the fact that the determinant of an upper triangular matrix is the product of the elements in the diagonal. Okay, so here I remind you of that. If you have some matrix and you arrived at some lambda 1, lambda n, and here you have zeros, so this is the main diagonal, and you have some other elements here. Let's call this one B. So here the determinant of B is just the product. Okay, we use pi to express that. So I going from 1 to n. So this is the determinant of B is the product of the element of the main diagonal. Okay, so we're going to use this fact here. So we're going to bring our matrix A to this form here. Okay, this is one way. Okay, so to do that, we will add all these elements. So we're gonna write the first column as a combination of all the other columns. Okay, so the first column, we will change it, we will add all the elements to it. Doing so, our A will become like this. So here we're gonna have A plus B plus A n minus 1 times. That means we're gonna have NA plus B, and the other columns won't change. Okay, we'll do the same thing. Okay, here, so this is the first column, so we're gonna add all the other columns to the first column. So we're gonna have the same thing, NA plus B and NA plus B. The others won't change. This one won't change. Here we have A's. Okay, and here we have A plus B, and we have A's. Now we can take this element outside. Okay, using the linearity, so we can take NA plus B outside. Therefore, our matrix will be NA plus B times, here we're gonna have 1, 1, 1, 1, and the others, they will stay the same. Okay, okay, great. Now what we're gonna do is, okay, you need to note that. So we're gonna fix the first column, first row, and we're gonna subtract replace the second row by the second row minus the first row. Okay, for each row. Okay, let's do it for each row. Okay, so we're gonna change this row here. We're gonna subtract this one minus this one, fixing the first row, and the other one we're gonna subtract the row from the first one. For each row we're gonna subtract it from the first one. Doing that, doing that, we will get, so we're still gonna have this coefficient outside, na plus b. The first row will be fixed. Okay. Now, if we subtract the first row from the second, we're gonna have 0, b, and zeros everywhere. And we see that if we subtract every row, okay, so we replace the row sub I, okay, row I, let's call it row prime I, will be replaced by row I minus row 1. Okay, so for I going from 2 to n. Okay, so the third one will be, okay, we subtract 1 minus 1, 0. Okay, a minus a is 0. But here we're going to have a plus b minus a, which is b. Okay, therefore we're going to have b's everywhere and zeros everywhere here. Okay, now do we know the determinant of this one? So this is an upper triangle matrix. Okay, therefore its determinant is the product of the elements in the main diagonal. Okay, so we have b to the power n minus 1. Okay, therefore the determinant, I should mention that here, starting from here, I should use this symbol because I'm computing the determinant. Okay, so the determinant of a is gonna be n a plus b times b to the power n minus 1. Okay, I use this fact here that I talked about earlier. Okay, so I'm here, I can use that. It can use that. We're gonna prove this result, or this is assumed to be known. Okay, so the determinant here is the product of the elements in the diagonal. If you don't want this one, you can expand according to the first row here. So you have 1, a, and you keep going until you find this determinant. Okay, so I hope this is clear. Okay? It's a bit quick, but we got all we need. So we did explain all the ideas that we need for the computation here. Thank you very much.